This is page 59, number 2. It's a series which is a power series. The term power series is used when you have a variable in here and the variable is taken to different powers. So this is a power series, and we want to show that it converges absolutely only when x is in this region. So visually this is -3, here's -1. Talking about those values of x that will make that series converge. So to achieve this, we're going to take the ratio of consecutive terms. So this is the ratio test. I take the ratio of consecutive terms, the absolute value of it, and I take the limit. And I find out what that limit is. If that limit is less than 1, then the series converges absolutely. So that's why I have these absolute value here. This is what it means for the series to converge absolutely. It means the absolute value of the individual terms converges. If L is greater than 1, then the series diverges, and if L equals 1, then we get no information. So let's take the ratio here. AN plus 1 over AN, that's equal to, it's a big fraction. So on top I have x plus 2 to the n plus 1 factorial over n plus 1 squared. That's the first term. It's the an plus 1. I replace everything that has an n in it with n plus 1. Then an is just simply that repeated. N factorial over n squared. So when I'm dividing a fraction by another fraction, I can just flip it and multiply. So this is equal to n squared over n plus 1 squared, and then I have x plus 2 to the n plus 1 factorial over x plus 2 to the n factorial. When I take the limit of this, as n goes to infinity, n squared over n plus 1 squared, that goes to 1. Okay, so you can determine that. So this term right here goes to 1. Now let's take a look at this other term here. This right here. This is equal to x plus 2. So what I have to do is, see, I have x plus 2 on the top, x plus 2 on the bottom. Those are the bases. I'm going to subtract the exponents. So that's n plus 1 factorial times n factorial minus n factorial. I'm going to write that. Minus n factorial. And n plus 1 factorial, that's n plus 1 times n factorial. There's just an extra term in front. So think of this as being 7 factorial, and this is 6 factorial. So 7 factorial has a 6 factorial in it. Just pull off the 7. Okay, so this is equal to x plus 2 to the n factorial. I'll factor it out. They both have an n factorial in it. And then I get left over n plus 1 minus 1, which is x plus 2 to the n times n factorial. Okay, so that's that term. Now we're interested in the limit. Okay, we're interested in, excuse me, this is x plus 2. We're interested in this limit being less than 1. So this part goes to 1. What does this go to? Well, it depends. So if the limit as n goes to infinity of a n plus 1 over a n is less than 1, if what? That means x plus 2 to the n times n plus 1. is less than 1. And that happens, so what does it mean for something to a power to be less than 1? That means that something had to be a power, or had to be less than 1 to begin with. So this implies that x plus 2, absolute value of x plus 2 is less than 1. Which implies x plus 2 is less than 1. Or x is less than negative 1. Or negative x plus 2 is less than 1, which gives you that x is greater than negative 3. So you get this region right here. It converges when x is greater than negative 3 or when x is less than negative 3.